Alright guys, today's lesson is on section 8.3, multiplying polynomials. In the first section, we are going to multiply a binomial times a binomial. So we are going to multiply an expression with two terms times another expression with two terms. The way that we're going to do this is we're going to have to distribute both terms in the first binomial by both terms in the second. A lot of you guys remember this by the acronym called FOIL, in which we're going to multiply the first terms, the outer terms, the inner terms, and the last terms. So in order to multiply problem number 1, I'm first going to distribute the first term in the first binomial, the x, times both terms in the second binomial. X times x gives us x squared. X times 2 is 2x. And then I'll distribute the second term in the first binomial. 3 times x is 3x, and 3 times 2 will give us 6. Double check to see if we could combine any like terms in our resulting expression, in which we can. 2x plus 3x are like terms, in which our answer will be the trinomial x squared plus 5x plus 6. Let's go ahead and practice moving on to problem number 3. Let's go ahead and distribute the 3a times the first term in the second binomial. 3a times 2a is 6a squared. 3a times negative b is negative 3ab. And now distribute the negative b times both terms in the second binomial. Negative b times 2a will be negative 2ab. And negative b times negative b will be a positive b squared. Can I combine any like terms? Yes, we can. Negative 3ab and negative 2ab are like terms since they both have ab in it. Negative 3 minus 2 will give us negative 5. Therefore, our resulting expression will be 6a squared minus 5ab plus b squared. Problem number 5 looks very similar to Problem number 5 looks a little bit different from the first two problems we just did, number 1 and 3. However, it is actually the same thing. N plus 9 squared means to multiply n plus 9 times itself. How are we going to multiply a binomial times another binomial? We're going to be doing the same procedure as 1 and 3. I'm going to distribute the n to both of the terms in the second binomial, giving us n squared plus 9n. And then I'll distribute the 9 times both terms in the second binomial, giving us 9n plus 81. Combining our like terms, 9n and 9n will give us 18n, resulting in our answer, n squared plus 18n plus 81. Notice in problems 1, 3, and 5, multiplying a binomial times a binomial, our resulting answer is a trinomial, or 3 terms, which does happen more often than not. However, problem number 7 is an example where we're not going to get 3 terms as our answer. Notice that what we're multiplying is almost the same binomial, except the first one has an addition sign and the second one has a subtraction sign. Let's go ahead and multiply, just as we did in the previous problems, and see what we get. B times b is b squared. B times negative 2 is negative 2b. 2 times b is positive 2b, and 2 times negative 2 is negative 4. We do have like terms, again, and they're usually in the two terms in the middle. However, notice that the two terms we have left, negative 2b plus 2b, is equivalent to 0. When you combine them, they cancel each other out, resulting in a binomial as our answer, or just two terms, b squared minus 4. What I'm going to ask you guys to do is pause the video, try the even problems, and then play the video back to check your answers. Here are your answers for the even problems, 2, 4, 6, and 8. Each even problem is very similar to the odd problem that it's next to. For example, problem number 8, again, when you distribute or double distribute, the two like terms in the middle cancel each other out, in which we're resulting in a binomial as our answer. Problem number 6 is just like problem number 5, such that when we have two terms squared, we have to remember that we're not just going to square everything inside, but we're going to multiply that binomial times itself, in which we're going to FOIL or double distribute to multiply. We're multiplying the first term times both terms in the second binomial, and then we're distributing the second term. In the last section of our notes here, we'll now have a binomial times a trinomial. Very similar, but now we have two terms times three terms. All this means is that we have an extra term to distribute to. I'm going to first distribute the m times all three terms of the trinomial. M times m squared is m cubed. M times 4m is 4m squared. M times negative 8 is negative 8m. And then we'll distribute the 5. 5 times m squared is 5m squared. 5 times 4m is 20m. And 5 times negative 8 will give us negative 40. Just as we did in the last section, we're going to now combine like terms if there are any. There are no like terms with m cubed, so our answer will start with m cubed. I could combine 4m squared and 5m squared to give us a total of 9m squared. Negative 8m and 20m could be combined to give us positive 12m. And lastly, there are no like terms with negative 40, so we'll tack that on at the end. Notice our answer here is in standard form of a polynomial, such that all the exponents are in descending or decreasing order. What I'd like you to do is pause the video, try problem number 2, play the video back to check your answer. Here's your answer for problem number 2. I'm going to go over the work really quick. We're going to distribute the t times all three terms of the trinomial, resulting in t cubed plus 4t squared plus 7t. And then we'll distribute the 3 times all three terms in the trinomial, resulting in 3t squared plus 12t plus 21. Combining like terms will give us our answer below, in which we're left with t cubed plus 7t squared plus 19t plus 21. Please let me know if you guys have any questions on the lesson, and I'll talk to you soon.